So here's a novel example that maybe falls a little bit outside of the mold of some of the other examples that we've been doing, although we've done already some varied examples here, I think. This is a little bit more about using the language or interpreting the language of proportions to look at something that involves kind of a pattern and some sequences. Turns out it's really similar to kind of some of the mathematical patterns that Galileo observed for describing free fall, which we'll study a little bit later in this course. So it says here, one night I am counting sheep. Instead of counting one at a time, I have the sheep jumping in sequential groups. Each time a group of sheep jumps, the number of sheep in the group is proportional to an odd number sequenced with the groups of sheep. So if I write some odd numbers, right, that would be like 1, 3, 5. So I'm a physicist. I know like mathematicians can get really cool notation for doing like sequences and maybe also series, but I'm a physicist. I'm just going to do numbers for this one, even though sometimes we do a lot of variables in physics, but I'm just going to do numbers here. That works for me. So I just started by writing down the odd numbers there, and then it says if the first group of sheep has 3, so I'm going to write that underneath here, 3. That's for this first group that corresponded to the odd number 1. The second group will have 9, which should be proportional to the odd number 3, and that kind of makes sense, right? Because 1 times 3 is 3. 3 times 3 is 9. And then it says the third will have 15. 5 times 3 is 15, right? Okay. And how many does the fifth group have, right? Well, that should be 7 times 3, right? So that should be 21 there. Okay. And I'm going to put in some dots here. Okay, there they are. Now, let's see. I keep referring here to like the number of groups. So I'm going to label this as group number 1, group 2, group 3, group 4, just to kind of help me keep track of things in a slightly different way. And then now we're talking about, let's see. So I think we answered the question of how many does the, let's see, the third will have, how many does the fifth group, oh, have we gotten to that yet? We need to do one more here. Maybe I put those dots a little bit too soon here. Okay, I can move them over. Right, I'll have them be there. Okay, so the fifth group would correspond to the odd number 9, and then 9 times 3 is 27. So that answers that. That answered the first question right there, the 27. But then it says, how many total sheep have jumped once the fifth group is over? So I think that means we're going to total up all of these numbers. So who wants to spend a little bit of time doing that? I'm going to say any small child can see that that's 75, right? I'm just kidding. But maybe there's a pattern that could help us arrive at that a little bit more quickly. Because if we look at this, it was 1 times 3 is 3, right? Here we have 1 and 3 gave us 9. But if I looked at the total here, 3 and 9 is 12. But 1 plus 3 is 4, which is the same as 2 squared. So there's this interesting fact that if you look at like, okay, 1 plus 3 is 4. That was for the second group, so it's equal to 2 squared. 1 plus 3 plus 5 is equal to 9, which is equal to 3 squared. There's a pattern here. Let's see if it works. The third one would be 3. Hang on, am I doing? No, sorry. The fourth one I did the 3 already. The fourth one I meant to say is 4 squared, which should be a total of 16. Well, let's see what happens if I have 1 plus 3 is 4 plus 5 is 9 plus 7 is 16. It's checking out. Do you guys kind of see how that's working there? It's maybe a little bit muddled where I'm seeing that, but basically I'm seeing that the totals, if I add up odd numbers, it's always just a square of whatever number of group I had. And then if I go, if I take that total and because what was I at right there? I think I had a total of 16, but 16 times 3 would probably give me the total of these right here. I don't know if I want to spend the time checking that, but let's check if that works here, right? Because for 5, if I took 3, so what I'm hypothesizing here is that the correct formula based on the group number is that 75 is equal to 3 times 5 squared. So if you followed all of that, congratulations, because I feel like I was a little confusing there somewhere. But this is, again, the kind of like mathematical hypothesis I'm forming here. I think that checks out, right? Because 5 squared would be 25 times 3 is indeed 75. So I'll just write that like that there. Again, I guess that's a little redundant, but whatever. But that's going to help me out with this last question because, boy, I really didn't want to have to keep writing this all the way up to the 100th group. right? I mean, I've got my odd numbers here. I can see that each number entered here was 3 times that, but it would have been a lot of work to put down the first 100 odd numbers and then add all of these up. So it's really neat if I have a simple formula, and the simple formula appears to be take 3 multiplied by the group number that we're given there, which is 100 in this case, square that, and let me see, I think 100 squared would be like 10,000 times 3 is 30,000, so I'll write that in that way. Or I guess if you really want to go scientific, you could say 3 times 10 to the 4 is potentially okay. But do I have all my answers? I mean, I think, let me see, this was one answer here, this is one answer here. I guess the first question though was like, how many does the 5th group have? That was that number right there. Just want to go back and make sure I've identified all my correct answers. Maybe I could have rewritten them at the bottom, but I think it'll be good enough that I underlined them. So we can go and check that now. There it is, 2775. And the hard one to get to was that 30,000.